Welcome dear student and Jai Swaminarayan. In the previous video, we were discuss about the reflection of the sound, echoes, reverberation, right, and the ultrasonic sound. What do you mean by the ultrasonic sound? When the frequency of the sound wave is greater than 2000 Hz, the sound is called the ultrasonic sound and the use of the ultrasonic sound. So in the previous video, we were discussed about the ultrasonic sound and the use of the ultrasonic sound. Ultrasonic sound is used in the to measure the distance in the submarine, right? That is the sonar. And in this video we will discuss how the sonar works, what is the structure of the human ear that can hear the sound wave, and the sound wave how the sound is heard by the human ear. So let us start with the first point, that is the sonar. So first of all, what do you mean by the sonar? Sonar stands for the sound navigation and ranging. So that may be asked in your examination, what is the full form of sonar? Sonar stands for sound navigation and the ranging. So full form of the sonar is the sound navigation and ranging. So sonar is a device which use the ultrasonic sound wave that has a frequency greater than 2000 Hz to measure the distance, direction and the speed of the underwater object. So sonar is a device which is used ultrasonic sound wave which has a frequency greater than 2000 Hz is used to measure the distance, direction and the speed of the underwater object, right? So sonar has a transmitter and a detector installed in a ship, right? In a ship the sonar is installed. The sonar has a transmitter which transmit the ultrasonic sound. It has a detector which detect the ultrasonic sound. The transmitter produced the ultrasonic sound wave which travel through the water and after striking the object in the sea bed is reflected to the detector. So here the ultrasonic transmitter is fit in the seat, right at the bottom of the seat. So this ultrasonic transmitter continuously produces the ultrasonic sound wave, right? This ultrasonic sound wave is transmitted through the water and it reflected from the underwater object in the sea, and the reflected ultrasonic sound wave is received by the ultrasonic receiver, right? So here how we can calculate the distance of the object from the ship? The distance of the object can be calculated by knowing the speed of the sound in a water and the time taken between the transmission and the reception of the ultrasonic sound wave. So here if the ultrasonic sound wave is transmitted from here and it is received here, so what is the speed of the sound wave in a water? So if you know the speed of the sound wave in a water, only we have to measure the time taken between the transmission and the receiving of the ultrasonic sound, right? So from the formula of the speed, speed is equal to distance divided by time. So from that, the distance is equal to speed multiplied by time. So if the time taken for the transmission and the reception of the ultrasonic sound is t, and the distance traveled is 2d by the ultrasonic sound wave. So in this side the d distance is traveled and in this side the d distance is traveled, right? So the distance traveled by the ultrasonic sound is a 2d, right? Is calculated by distance 2d is equal to speed v into time t. So from that the distance of the object can be calculated by speed of the sound in a water v into t time taken between a transmission and the reception divided by 2. So for that, what is the speed of the sound in a water? So this we were discussed in the previous video. So what is the speed of the sound wave in a water? That we were discussed in the speed of the sound. The speed of the sound wave in a sea water is a 1531 meter per second, right? So we can know the speed of the sound wave in a sea water. The speed of the sound wave in a distilled water is a 1498, right? So we take the speed of the sound wave in a sea water is the 1531 meter per second. So if you know the speed of the sound wave in a sea water 1530 meter per second, and if we measure the time taken for the transmission and the reception for the sound, we can easily calculate the distance of the object from the ship, right? So dear student, understand what do you mean by the sonar, and what is the use of the sonar, and what is the use of the ultrasonic sound wave in the sonar device. Now we will discuss about the structure of the human ear. Human ear and how the sound is heard by the human ear. So here the structure of the human ear is shown in this figure. So the outer part of the human ear, that is called the pinna, that collects the sound wave, right? So the sound wave collected from this pinna, outer part of the human ear, can transmit through the, it passes through the ear canal and reach to the eardrum. So as the sound wave reach to the eardrum, it vibrates, right? And the vibration of the this sound eardrum can be amplified with the help of the three thin bones called the hammer, anvil and stirrup, right? So here the sound wave which received from the pinna is transmitted through the ear canal to the middle parts of the ear. So in the middle part of the human ear, eardrum is there. So as the sound wave strike through the eardrum vibrates, right? And the vibration of this eardrum are amplified by the three bones called the hammer, anvil and stirrup, right? So this amplified sound wave now converted into the electrical signal by the cochlea. So in the inner part of the ear, the cochlea is there, and this cochlea converts the sound wave into the electrical signal, and this electrical signal is passing through the nerve system to the brain, and brain interpret this type of the electrical signal, and as the brain interprets the sound signal, we can hear the sound, right? So this one is the structure of the human ear. So in this human ear, Eustachian tube is there. It supports, it is used for the support and the equilibrium, right? So the structure of the human ear is a simple, right? So outer part of the human ear, that is called the pinna, that collects the sound wave. The outer ear called the pinna collects the sound wave. The sound wave passes through the ear canal to the thin membrane called the eardrum. So this sound wave collected by the outer part is passes through the ear canal, right? So this one is the ear canal and reach to the thin membrane. This thin membrane is called the eardrum. So as the sound wave strike to the eardrum vibrates. The vibration of the eardrum are amplified by the three bones of the middle ear called the hammer, anvil and stirrup, right? The middle ear then transmit the sound wave to the inner ear. The inner ear, in the inner ear, the sound wave are the converted to the into the electrical signal by the cochlea and sent to the brain through the auditory nerves. The brain then interprets the signal as a sound signal. So this way we can hear the sound, right? So how we can hear the sound? So sound is received by the outer part. The sound wave is transmitted to the ear canals, reach to the eardrum. So as the sound strikes to the eardrum vibrates. And this vibration of the eardrum amplify with the help of the three small ones, right, called the hammer, anvil and stirrup. So this amplified sound wave is transmitted to the inner ear. In the inner ear, cochlea is there. The cochlea converts the sound wave into the electrical signal, right, and this electrical signal is then passed to the brain through the auditory nerves, right? The brain interprets and analyzes the signal as a sound wave and we can hear the sound, right? So dear student, understand the structure of the sound and how we can hear the sound. So dear student, this point is important for the examination also, right? Draw the structure of the human ear and explain, right? So you have to draw the structure of this human ear. I hope that you understand both the point sonar and what is the use of the sonar and structure of the human ear and how we can hear the sound. Thank you very much for watching my video.